Hello there, ladies and gentlemen. In this video, we're doing an integral. It's actually an improper integral because you can see that when x is 0, we're doing 2 divided by 0 here, and 0 is our lower limit. So this is going to be an improper integral. Let's go straight into it. Let's not faff about. So the first thing that we should do for any improper integral is we should rewrite it using a limit. So this is going to be equal to the limit as, let's say, t goes to 0 of the integral from t to the square root of 27 of 2 over x plus the cube root of x. Okay, lovely. Now this is the kind of proper way of doing it. Now we should actually try and tackle the integral. So hopefully it's fairly obvious that a substitution would be quite smart here. In particular, I think we should say let maybe u equal the cube root of x, or that's x to the power of a third. Okay, I think that's pretty sensible. And then let's work out what dx is in terms of du. So du dx would be a third times x to the minus 2/3. That means the du would be a third times x to the minus 2/3 dx. And then times both sides by 3, times both sides by x to the power of 2 over 3. You're going to have the dx is 3x to the 2 over 3 du. And finally, x to the power of 2 over 3 is actually just u squared, okay, because u is x to the power of a third. So dx is 3u squared du, okay? So let's rewrite this. So we've got our limit as t goes to 0 of the integral, and we'll do the limits in a second, but let's do the actual integral here. So we've got 2 over x is going to be u cubed, if that makes sense. We've got the cube root of x here, that's just u, that's how we defined it, and dx is just going to be 3u squared du, so 3u squared du, just like that. Now you can see that we can do a bit of cancelling, a bit of simplifying here, but let's actually replace our limits now. So this might be slightly tricky, hopefully not too bad. The lower limit will be quite easy, right? So when x is t, that's the lower limit, we've got that u is the cube root of t, or t to the third. So I can put the limit down here as t to the power of a third. Hopefully that's quite straightforward. Now without a calculator, we need to work out what the square root of 27 to the power of a third is, right? Because when x, let's write this down, when x is the square root of 27, we've got a situation. So if x is the square root of 27, what is u? Well, we need to do the square root of 27 to the power of a third. Without a calculator, this might seem slightly daunting, but actually it's not, because 27 is 3 cubed. So this is the square root of 3 cubed, and then to the power of a third. And if I do a little bit of manipulation here, I've basically got 3 to the power of a third. The square root is acting as a half power, and then I'm doing a third power. So there's a lot going on, but actually you can remember this is a property of powers, especially if the base number here is a positive number. We've got 3 to the power of 3 times a half times a third, and then the 3 and the third cancel, so we have 3 to the half, which is the square root of 3. So that's our upper limit, okay? The upper limit is the square root of 3, so we can plug that in there as well. So there's our square root of 3. Now we can rewrite, but we can do a little bit of simplifying, so we can cancel some stuff out. So we have the limit as t goes to 0, integral t to the power of a third, the square root of 3, and then we've got 2 times 3 is obviously the number 6, and then 1 u from the top and bottom can cancel, so we've got 6u over u squared plus 1 du. And this integral is fairly straightforward, so you can actually do this by substitution if you like, or some people might be able to just see it because it's kind of what you might call the reverse chain rule here. So essentially, if you think about the derivative of the natural log of u squared plus 1, what does the natural log of u squared plus 1 differentiate to? What is that? The natural log of u squared plus 1. What's the derivative of that? Well, it's going to be 2u over u squared plus 1 because of the chain rule, okay? And we don't have 2u over u squared plus 1. We have 6u over u squared plus 1. So in order for it to differentiate to 6u over u squared plus 1, we need a 3 out here. Okay, that's how we know how to do that. Okay, that's the fast way. Okay, and then we've got our, t to the power of a third, and we've got the square root of 3 here. Let's rewrite. So we've got the limit as t goes to 0, open bracket, we can plug in the square root of 3. So 3 times the natural log of the square root of 3 squared is 3, plus 1, that's the number 4, so just 4 there. And then we're going to subtract 3 times the natural log of, and then this is going to be t to the power of 2 over 3 plus 1, like that, okay? Now we need to work out what is going to happen as t goes to 0. Okay, so as t goes to 0, we're raising it to the power of 2 over 3. That is going to get smaller and smaller and smaller and smaller. So it's going to go to 0. Okay, so as t goes to 0, if you square it and then you cube root it, it is just going to go to 0. So that gives us 3 ln 0 plus 1. Okay. And that finally, once we've actually taken those limits, we can see the final answer is going to be 3 times the natural log of 4, because this term here vanishes, because basically as t goes to 0, t to the 2 over 3 goes to 0 as well. Okay, that's the idea. So that's the final answer, 3 times the natural log of 4. So it's a little bit funny. Make sure that you're dealing with the improper integration stuff properly, because it's very easy to just like forget about it and just be like, whatever. This question is also quite interesting, because when you do the substitution, when you get to this point over here, it actually doesn't look like an improper integral. And that can be quite deceiving. So you've got to be careful about that, because it is an improper integral. Anyways, guys, as always, I really appreciate you watching all the way to the end. If you enjoyed the video, then like, subscribe, share with your friends, family, and even your enemies. And I'll see you in the next one. Cheers.
Watch your list back on your television.